Okay, so for what we have in number 5, we're looking at a blend of a radical and a rational expression, and this time we have the square root expression to be in the numerator of the fraction. Now for the domain of this expression, okay, we must have the domain of both the square root of 4x plus 1 to be satisfied, and also x squared minus 9 cannot be equal to 0. Okay, so we have two sets of domains, okay, to be satisfied. Okay, and so we have, just going back, okay, we had the square root of 4x plus 1, which consists of this domain where we had the set of all values of x, whereupon x will be greater than or equal to negative 1/4. And back in number 2, we had x squared minus 9, which we could not have to be equal to 0, and it was from the restriction that x squared minus 9 could not be 0 that, okay, we had the domain to comprise other restrictions that x cannot be negative or positive 3. And so in just looking at encapsulating what we have to satisfy both domains, okay, so we have again for the square root 4x plus 1, okay, we have the domain to be the set of all values of x greater than or equal to negative 1/4, and again for x squared minus 9, for this to not be equal to 0, again we have leaving out the values of negative and positive 3. Now, in looking at the set of values that will belong to both of these domains, and thus the result for number 5, again I have laid out, okay, some graphs that will regard the domains of both the square root of 4x plus 1 as well as that which disallows x squared minus 9 from being equal to 0. Now for what we have in the case for the domain of the square root of 4x plus 1, again we had the set of all values of x greater than or equal to negative 1/4, and so from a graphing standpoint on a number line you have a bracket on negative 1/4, and then we have a ray going out to the right, okay, proceeding to infinity. Now if you notice I have included the negative and the positive 3, and this is going to be in relation to what we have in the case of the domain of that which disallows x squared minus 9 from being equal to 0. And so for that other expression, okay, so for the domain of x squared minus 9 not being equal to 0, okay, we're looking at, again, the exclusion of negative and positive 3, and so we have from a number line perspective, again, you're going to have parentheses or a hole located at negative 3, likewise at positive 3. So you have for this ray going out to the left, this will be the set of values of x which will be less than negative 3. For the line segment that we have in the middle, this is for what we have greater than negative 3 but less than 3. And then we have for the ray proceeding to the right, we have those values greater than 3. Now, in terms of that which will belong to both domains and thus comprise the domain of the square root of 4x plus 1 all over x squared minus 9, again for the set of values, okay, that will belong to both of these domains and thus provide our solution in number 5. If you notice, okay, for the values of x less than negative 1/4, this will belong, okay, for the most part except for negative 3, okay, to the domain of x squared minus 9 not equal to 0. So you don't have a commonality between the graphs of both domains. But as we go past, start at and go past negative 1/4, you begin to see a set of common values. So you have an intersection. So you got negative 1/4 will be included, and then we have going up to, okay, proceeding out to 3. So at least we have a set of values in common between negative 1/4 included out to essentially 2.99999. Okay, and then we have for the values of x that will be greater than 3, okay, that set of values will belong to both of these domains. And so for what we have intersecting with that, which we have common to both domains, okay, so you have including negative 1/4, excluding 3, but for everything else we have greater than or equal to negative 1/4 except for 3. And so for the domain of what we have for the square root of 4x plus 1 all over x squared minus 9, we have this set of values. So you have from negative 1/4 included, then we have excluding 3, but everything else that is greater than negative 1/4 will belong in the set. And so we have going from negative 1/4 closed, approaching 3 open, then going past 3 open, on out to infinity. And so we have for number 5, it turns out that for the domain that we have these two intervals, okay, comprising the solution.